All right. So the next unit that we're going to be talking about, right, will deal specifically with square roots and also cube roots. Okay. So we already kind of dealt with square roots a little bit, right? Like simplifying square roots, especially when we were dealing with like the quadratic formula and stuff like that. But that was merely like simplifying square roots, right? We also use square roots in like equations and stuff like that when we're solving quadratic equations. Right? So now we're going to be graphing square roots. And of course, with the graphing, we're going to talk about transformations and all that jazz too. Okay? So that's what we're going to be getting into today, looking at the parent function for the square root of x. I think just for the square root today. Yeah, just for the square root of x. And then we'll also talk about transformations and stuff like that too. Okay? So before we do that, though, let's take a look here at the inverses of simple quadratic functions. Okay, and we'll also their graphs. Okay, so that's what we're going to be looking at today. The inverses of simple quadratic functions and then their graphs. Okay, so get this reoriented. There we go. All right, so let's see what we got here. So for example, we'll just jump kind of right into an example here. Let's say we want to find the inverse of f of x. Okay, those are our directions. All right, and I'll start with our function here. F of x is equal to 3x squared. Okay. Now again, I know I can remember from Unit 1, right? We're a little rusty. We were a little rusty then in Unit 1 about finding inverses. It's been a while since we've done it, so, might be a little rusty still. But the principle, the way we do it is still the same as what we just did here in the warm-up, right? And that's why I kind of gave this to you in the warm-up here. All right? So the first thing we're going to do is change f of x to y equals 3x squared, right? Because f of x and y, they're kind of interchangeable, right? So we'll say that right here. So change f of x to y. Okay? And then what do we do? Once we change f of x to y, what should we do next? To get the inverse here, what should we do? Next step. Swap the x and y. Exactly right. So we have x equals 3y squared. Okay, so yeah, swap x and y. Okay. And then to finish getting our inverse, what do we do now? What should we do next? Bless you. Solve for y. Yeah, get the y by itself. Yeah, okay. So in this case, right, to get the y by itself, we have a 3 with the y and we have a square with the y. So let's go rid of that 3 first. We'll divide both sides by 3. Or I like what CJ said during the warm-up. Let's multiply by the reciprocal of 3, right? So instead of dividing both sides by 3, let's multiply by the reciprocal. What is the reciprocal of 3? 1/3. So we're going to multiply both sides by 1/3. Okay? So we get 1/3 x, and the 1/3 times 3 cancels, equals y squared. And then to get rid of the square, what do we do to both sides? Square root. Exactly right. Square root both sides. Okay? So you get y equals, now, we square rooted in an equation setting here, right? We square rooted in an equation setting. So when I square root in an equation, what do I need to put in front of my square root here? Plus or minus. Very good. Plus or minus the square root of 1/3x, just like that. Bless you. Okay? So in other words, then, f inverse of x is plus or minus the square root of 1/3x. Okay? And that's what we're going to be graphing today. Now, I'm going to graph this on the graphing calculator to show you what this looks like. Okay? Now, there's no plus or minus button on your calculator. All right? So in order to graph this, we're going to have to graph two functions. Okay? There's no plus or minus button, so we're going to have to graph two functions. All right, the first one we're going to graph is positive root 1/3 x. So just square root 1/3x. Okay, I put 1/3 in parentheses there, just like that. And then we'll also graph negative. So negative and then square root 1/3x. Okay. You're all okay with finding the square root button and stuff like that on your calculator, right? You know where that is? Square root, it's second and then x squared, Mike. Second and then the x squared button. You can see it right there. Okay. All right. I'm going to press zoom 6 just to put it back to the standard viewing window there. All right, there's the plus square root of x. There's the negative square root of x. Now, is this inverse a function? Is this inverse a function? No, why not? The vertical line test, exactly right. Okay? It's a problem, right? Because we're very used to having functions that we deal with, right? Where if I give you a particular x value, you know that there is one y value attached to that x value. But in this situation, right, if I give you an x value of, say, like 3, you're going to have two y values attached to it. With an x value of 3, you could have this value or this value, right? Both of them are true. And that's kind of weird to get two different answers to the same input, right? And so what we're going to end up doing here, okay, is when we talk about square roots, we're not going to be talking about the plus or minus here. Okay, when we find the inverses, we're going to rewrite these inverses so that they are functions. But in order to do that, we have to go back to the original function here. So let me graph this original function along with its inverse here. Okay, let me do this zoom square to make it more obvious. Okay, so there are the inverses, or the inverse, I should say, right there. And then there's the original function right there. Okay? And you can see here, or maybe you can't see, but there's a reflection happening, right? If I also graph the line y equals x, okay, there's our original function, there's its inverse, okay? And you can see there's a transformation that happened here. We took our original function, and it really is just a reflection over this diagonal line y equals x that results in this function right here, okay? That's that reflection. And you might remember seeing that reflection in like geometry or something like that. If you can remember back to geometry last year, or maybe last semester, depending. You saw a reflection that resulted in this, okay, over the line y equals x. And that is what an inverse does, okay? So what we're going to do is we're going to limit this graph. We're going to limit this graph. We're going to restrict it so that when we take its inverse, we'll have a function, okay? So Cheyenne said this thing's not a function because it fails the vertical line test. But if you take a vertical line and you reflect it over this line y equals x, it becomes a horizontal line. And so a horizontal line here, right, is going to hit 2 points. And so that's how we know that the inverse of this function will not be a function itself. All right. Long story short, here's what we're going to do. All right. We're going to go back up to our original function here, and we're going to restrict it. We're going to say only for x values greater than or equal to 0. Okay, in this case. So we're going to add in this little restriction. Okay. So I'm only going to consider this function right here when my x values are greater than or equal to 0. So if I go turn everything off here so we can just focus on the function. Okay. Which part of my function here, what part of my function, okay, contains x values greater than or equal to 0? What part of the function contains x values greater than or equal to 0? How would you describe it? What part of this function here contains x values greater than or equal to 0? Okay, but everything's above the x-axis, right, except for the 0. You're on the right track, though. So we're going for x values greater than 0. That's this side, right? So it's to the right of the y-axis. Yeah, there you go, Shane. Yeah, right of the y-axis. So notice we only want this half of our quadratic. You can actually get your calculator to graph this, believe it or not. If you take that 3x squared and you do divided by, and we'll do parentheses, okay? Actually, maybe I should put that whole thing in parentheses too, the function. Okay, so you can actually have your calculator only graph part of a function. If you divide by, and then we want to divide by this, x greater than or equal to 0. Okay, so I'm going to type in an x, and I'll put the greater than or equal to there as second math, and then there's the greater than or equal to. Okay, second math takes you to the test menu, and that's where you can get your greater than or equal to, less than or equal to, all that jazz right there. Okay, and then 0. And when I graph it now, it will only graph the right-hand side of my function. Yep, sure. So I'm graphing the 3x squared, okay, and I'm dividing by x greater than or equal to 0, and that allows me to only graph the right half of the function. Okay, if I wanted to graph the left half, I would graph for x less than or equal to 0.
And then how do you go to the...
To do that second math, and it gets you to this menu where you can pick your different inequality symbols and stuff like that. Okay? So it should look something like this, for that 3x squared divided by x greater than or equal to 0. Okay? Now, let's say I take this, right? So now we're only working with the 3x squared part that's greater than or equal to 0, so it's the right half of my quadratic there, right? Let's say we take that, right, and I want to reflect it over this line y equals x to get its inverse. Okay? I'm going to take it and reflect it over the line y equals x to get its inverse here. And so then that'll result in what two pieces here of my inverse? Which one of the two pieces is the reflection of this positive, this x greater than or equal to 0 part of 3x squared? Which one of these two pieces right here? The top one, right? The top one. And so going back to the graph, which one of these two is the top one? The positive square root of 1/3 x or the negative square root of 1/3 x? Which one's the top one? It's the positive one, yeah. Okay? So in other words, we're just going to go ahead and eliminate this negative one, and we'll just keep focusing on the positive one for that inverse there. Okay? So now it's a function, because if I now eliminate that negative one, and I just graph the positive one, right? So there's my positive square root of x, there's the positive side, and then you can see the reflection there, right? That this would reflect to be that. Okay? A lot of work, okay? Just a lot of, like, you know, little details there, just get to a point where we can say, you know, we want our inverse to also be a function in these cases, okay? So we restrict the original function so that when we take its inverse, we also have a function too, okay? We don't want our inverse to not be a function not be a function. All right, so that's why you're going to see me writing these little restrictions, okay, at the start here for the next problem that we're going to do, because we want the inverse to also be a function. Okay, so let me go through a few more here just to kind of, you know, help clue you in with that. So let's do f of x equals 0.5 x squared for x greater than or equal to 0. Okay. Sure. Mm-hmm. Okay. So again, we're going to have this quadratic, but we're only going to be graphing the right half of the quadratic, right? For x values greater than or equal to 0, so I'm only going to graph the right half of it. It's not shifted left or right, up or down at all. Okay, still has the origin. And so we'll go ahead and find its inverse. Okay, so y equals 0.5 x squared. Okay. And then what should we do to both sides here? Well, sorry, what should I do first now? I changed f of x to y. Swap the x and y, you got it. So x equals 0.5 y squared. Okay. And now what? How can we get rid of that 0.5? What can we do to both sides to get rid of that 0.5? We can divide both sides by 0.5, that's true. Or we could multiply both sides by... Right, and what's the reciprocal of 0.5? What's 1 over 0.5 going to be? Do you know? It's kind of hard to determine, right? Maybe we should change the 0.5 to a fraction. What is 0.5 as a fraction? 1/2. What's the reciprocal of 1/2? 2. We're just going to multiply both sides by 2. Okay, that'll cancel out the 0.5 there. We'll have y squared equals 2x. And then final step here to get the y by itself. Square root both sides. Okay, so you get y equals. Now again, I'm square rooting in an equation setting. I should put a plus or minus. But because of this restriction, right, I restricted only x values greater than or equal to 0. So which one of these signs can I get rid of, the plus or the minus? I can get rid of the minus, right? And so we're going to focus just on the positive root 2x there. Whoops, or I could also write it this way. Okay, with the inverse stuff. Sorry, and that whole thing is in the square root. Okay. So again, by restricting the domain up here, we're able to not have to worry about both plus and minus there. We can just do the positive version. Okay? So far, so good? All right. Let's do one more here together, and then I'll have you guys try one on your own. Okay. Okay. And this one I'm going to change up. So for this one, I changed up my restriction. For the first one, right, I was talking about we wanted only sides, we wanted x values greater than or equal to 0. That was the right side of my quadratic, right? And then up here, too, we've said x greater than or equal to 0, so that was just the right side of that quadratic. Now I'm talking x values less than or equal to 0, which means that's what side of the quadratic? For less than, we would be to what side? The right or the left? The left now, okay? So we'll see how that changes things up a little bit here. Right. We'll still change f of x to y, make it x squared minus 7. Okay. What would I do here to get that? Oh, sorry, I got to swap things around. I keep forgetting that step. Okay, so swap the x and y. What would I do here to get the y by itself?
1.
Yeah, there's a 1 in front of the y, is what you're saying?
Yeah.
True. Okay. We can multiply both sides by 1. It won't change it, so we can do that if you want to, but I'll just leave it because it's going to stay the same value. What else is with the y that we got to get rid of? Square, and what else? We have a minus 7, so I'm going to get rid of the minus 7 first. We'll add 7 to both sides, so we have x plus 7 equals y squared. And then, yeah, how can we get rid of the square? Square root, right, square root both sides. So we get y equals plus or minus the square root of x plus 7. Okay? But now, should I get rid of the plus root x plus 7, or should I get rid of the negative root x plus 7? Remember, we only graphed the left side of our quadratic. So we want to get rid of the plus 1 in this case, right? Because we're graphing the left side, we want the negative root x plus 7 there. Okay, which again I could rewrite as f inverse of x equals negative root x plus 7. Okay? So that's the idea. Okay? And again, our goal there was just to try to get things to match up. I'll show you what this one looks like here too real quick. So let's see here. X squared minus 7 divided by x less than or equal to 0. So again, you can see I'm graphing the original function there. Whoop. Okay, I'm graphing the original function, and I'm restricting it for x less than or equal to 0, and there's its graph. Okay, right there. I'll also graph our inverse here. We said it was negative root x plus 7. Okay, graph that. Okay, there's the inverse we're saying. And if I graph the line y equals x, you'll be able to really easily see that reflection, right? You can see this reflects over that line y equals x to become that, right? You can see also that if we eliminated the wrong thing, if we said it should be positive here, right? It just doesn't look right when we try and match it up, right? There's our graph, and we're saying that's the inverse. But you can see the reflection just doesn't quite match up, right? It's just not quite right. So 90% of the time, you're not going to have to worry about the sign. 90% of the time, you're not going to have to worry about the sign here. But I just wanted to show it to you just because, you know, it is important. Okay, so here's one for you all to try. All right, so find the inverse of f of x. Okay. There you go. And we'll say So again, if the sign part is confusing you, then don't worry about it for right now. Just get the inverse. Okay, if you can just get the inverse, that's like 80% of the battle right there. Okay, if you can get that inverse, that's like most of the battle right there. That's mostly what I'm concerned with. Okay, mostly what I'm concerned with. So just try and get that inverse. numbers, okay, using the exact same techniques we did from the warm-up, right? And then if you want to take that extra step, determine whether it should be the positive version of the square root or the negative version of the square root. Okay, and I'll do it 2 here real quick. Rewrite that best we can. Yep. Let's see. Yeah, that looks good. You do the positive version. Yeah. Looks good. One square root of 1/16 is? 1/4. Yeah. Make it a fourth, you want to simplify it even more. And then you can pull that 1/4 then outside the square root. Sorry, I'll take it. Right here. So remember you have to divide the 16, right? You had 16y squared, you want to divide, so you 1/16 there, x. Because you divide the 16 over.
Oh, yeah.
Right, because you have 16y squared, to get rid of it, you want to divide both sides by 16, or multiply by 1/16.
Mr. Whitmar?
Yeah.
How are you doing?
Yeah.
This is actually
Okay, did you swap your x and y? You did, so now what's with the y that you need to get rid of? 16, how do you get rid of 16? Divide both sides by 16, yeah. So you can multiply by 1/16 for the x. Okay. And so you have y squared equals x over 16, right? I got it. Okay, yep, and then finish off. Good. Good job. That's right. Good job. You want to get it actually? Yep, some more. Yeah, on the right track. You're got the y by itself, though. What's still with the y? You can get rid of there. Peyton, you all right? Feeling tired? All right. So, f of x equals 16x squared. Change it to y equals 16x squared, right? Swap the x and the y, so we have x equals 16y squared. You can divide both sides by 16, or you can multiply both sides by 1/16. It's really your choice, all right? I divided by 16, but then I changed it to 1/16 x, okay? Square root both sides, and so we get y equals, and you should have chosen the positive square root of 1/16 x there. Positive square root of 1/16 because our x values started out greater than or equal to 0. So that reverts to, that changes to then y values being greater than or equal to 0, so positive there, okay? And then you could stop here, but this does simplify, believe it or not, because you can break up a square root, right? Like with a product here, we made the square root of 1/16, which is 1/4, and then square root of x. So you could say this as well, okay? Either one of these is okay. Okay, either one of those is okay. If you just said root 1/16 x, or if you said root x over 16, that's fine, but also it does simplify to 1/4 square root of x, okay, which is helpful maybe to see. All right, questions on any of that? When Nate comes back, yes. All right. Now, all that to say, our parent function, like I said, our new kind of like function for the unit, okay, so the theme of this unit is going to be square roots and cube roots, okay? So we're going to get into the parent function for the square root today, okay? Parent function of the square root. So, Oh, I'm sorry to ask. Were there any questions, by the way, about?
Wait, can you go back for a second?
Yeah. Sorry, Mike. Is that good right there? Did you have any questions on anything?
No, I need it.
Just needed to see. Gotcha.
Oh, wait, can I see it?
Yep.
No.
Okay. Graphing square root functions. Okay, so now we're going to be graphing. And of course, we're going to reintroduce, review all those transformations we talked about in the past, right? So, let's talk about graphing. F of x equals the square root of x. All right? And let's go ahead and make a chart here, make a table. Okay? Now, when it comes to picking our x values, because when we make a table, right, we kind of have, like free reign to pick whatever x values we want. Should we just pick any old x value here for this particular function where we're going to graph it? Or can we be smart about how we pick, or how can we be smart about the x values that we pick here? What kind of x values do we want to pick? What would be an example of a good x value? What would be an example of a bad x value to pick? And again, if we're trying to do this mentally, what would be the example of a good x value to plug in here? What would be an example of a bad x value for us to try and plug in here? Yeah. Okay. So give me a bad example, Cheyenne. 17. 17 is not a perfect square. Can you pick 17? Sure. You can put in your calculator and get this like nasty decimal that goes on forever and never repeats. Your choice. Okay. But let's pick some nicer numbers. What would be a nicer number to pick there, Cheyenne? Yeah, 4 would be a great one. Okay? Because 4 is a perfect square. When I plug 4 in here, what is the square root of 4? 2. Okay? There's some other perfect squares, though, that are less than 4. What other perfect squares can we pick? What's a perfect square less than 4? What's that? 1. It's a great one. Yeah, don't forget 1. Okay, what is the square root of 1? 1. Okay? There's a perfect square less than 1. What about 0? What's the square root of 0? 0, yeah. Okay? And in fact, this point right here, this point 0, 0, that's going to be important to us. That's going to be the first point we kind of find. You can kind of think of it like the vertex or whatever. Okay? And I don't want to call it the actual vertex. What do I want to call it? Like the center point or? I don't know. Yeah, I mean, it is at the origin. That's true. I'm just going to call it the starting point. Or maybe like a reference point. Okay, that's reference. Wow, I didn't really write that very clearly. That's supposed to be the word reference there. Reference point. And why do I want to identify that? Well, just like when we did quadratics and we identified the transformations by the vertex, right? It was that vertex that we transformed first, and then we did everything else along with it. Or with absolute value functions, where we, again, had the vertex, we transformed it left, right, up, or down, and then we did everything else with it. Or just like when we did with like cubics, okay? And that center point, like a reference point kind of thing, we use that as well. This 0, 0 is going to be like our reference point, the starting point of our square root that we use to transform everything else. Okay. So we can pick some other perfect squares here. 9, right, gives us 3. We could also be, if we want to be fancy, we could do something like, 1/4 here. What's the square root of 1/4? 1/2. Yes, very good. Square root of 1 is 1. Square root of 4 is 2. So the square root of 1/4 is 1/2. Okay. So let's go ahead and graph this and see what it looks like. I mean, you kind of already have an idea because of the inverse stuff we did earlier, but I'll go ahead and graph it anyway. Okay. So what I'll do is I'm going to count by 2's on my x-axis here, just so I can fit in some of those points that are further away. Okay, and then I'll count by 1's on my y-axis. If you don't like that, you can feel free to count by 1's on both or count by 2's on both, your choice. But you don't have to count by the same scale on both axes. So we'll plot the points, right? We have the 0, 0. Maybe I'll do this in a different color to better. So 0, 0, and then 1, 1, And then the next nice point we have is 4, 2. And then 9, 3. And then I can also do the 1/2, 1/4. No, that's going to be really hard for me to plot, but something like right there. Okay, connect the dots. It looks something like that. So there's our parent function the square root of x. Okay, half a parabola. Half a parabola, right? It's like half a parabola on its side there. Or I should say it's really a reflection. Okay, questions so far? Makes sense, right? All this stuff, we've seen this. All right, well, here we go again. Transformations of the square root of x. All right, so here one more time. F of x equals a square root of x minus h plus k. Okay. Let's do the h first here. Okay. What is that minus h going to do to our function? Move it left or right. Exactly right. Okay. So if h is positive, okay, we're going to shift right. H units. Okay, if h is negative, shift left. H units. Okay. Okay, what's that plus k at the end going to do? Move it up or down, right? No surprises. If k is positive, we're going to shift it which direction? If k is positive, we'll go up or down? Up, up, up. It's so be careful here, right? With the h, right? With the h in there with the x, it's the opposite of what you'd expect, right? So when we do x minus 2, for example, that's going to be a shift to the right. But then x plus 2 would be a shift to the left. But then on the outside with the k value there, that is exactly what you'd expect. You go up with a plus, you go down with a negative. So if k is positive, we're going to shift up k units. Okay, and if k is less than 0, we're going to shift down k units. All right, and then what does that a in front do? What does the a in front do? Stretch or shrink. And if a is negative, it also can make it reflect or flip over the x-axis. Yep, very good. Okay. See, I told you guys these are going to show up again and again. And guess what? We're going to see them next unit and next unit. Okay, so they're not going anywhere. All right. So again, the better you can get them down now, the more it's going to help you later. Easier it'll be later. Okay. Vertical stretch if a is greater than 1. Vertical shrink if a is less than, if 0 is less than a is less than 1, so if a is between 0 and 1 there. Okay, and then finally, if a is less than 0, flip over x-axis. Okay. All right. So we'll do 2 examples here, and I'll get you guys started on your assignment. 2 examples here, we'll get you started on the assignment. Okay. All right, let's take a look at our first example here. Bless you. So we're going to describe the transformation from f of x equals the square root of x and graph. Okay, so we'll describe the transformation from our parent function f of x equals the square root of x, and we're also going to graph the answer too. Okay, so first one, g of x. We'll say it equals 2 times the square root of x minus 3 minus 2. Okay. 2 times the square root of x minus 3 minus 2. Okay. So there's our function we're looking at, the transform, or its transformation of the square root of x. So Samantha, can you identify any transformations here that you see in this function? Okay, so down 2, yes. Careful, not left 3. The minus 3, it does the opposite of what you'd expect. So minus 3, you think, oh, it should go to the left, but actually it's going to go to the right 3. Did I mess that up? Oh, so Julian, the minus h there. So if h is positive, right? If I say h is positive, it means you're going to have x minus a positive number. That's what I'm trying to say there for the formatting. You see that? But that is, so I can see, yeah. If we had x minus a negative, that'd become a plus positive. But yeah, I know. There's not an easy way for me to write that necessarily. But anyway, okay. So in summary, we're going to go right 3. We're going to go down 2. Okay. What about that 2 in front? What's that going to do? Anybody?
That 2 in front is going down.
Th- this 2 right here.
Down?
Yeah.
Shift. Stretch.
It is a stretch.
Yeah.
How much?
Stretch 2.
Times 2. Yeah, we're going to get times 2 bigger. Okay, so stretch by 2. Okay, so our heights are going to double. All right, so let's see what that means. All right, so think back to our parent function here. All right, and we're going to think back to 0, 0. Okay, we're going to think back to 0, 0 here. So 0, 0, we're going to move that, according to Samantha, we're going to go right 3 and down 2. So right 3 and down 2 means that the 0, 0, well, if I count, kind of right 3, so 1, 2, 3, and down 2, 1, 2, I'll be at 3, negative 2. Okay, so I'm going to go ahead and make a table here. Okay, I'm going to start it at 3, and I know we're going to get the y value of negative 2, and that's just from counting. Okay, 0, 0 goes to 3, negative 2. Okay, right, that normal kind of like reference point, our starting point there of 0, 0 goes to 3, negative 2, because you go right 3 down 2. Okay? So again, that was like our 0. Okay? The next perfect square that we use is 1. But we have to shift that as well. Okay, we have to shift that as well. So 1, right, if we're going to go right 3, what's right 3 from 1? 4. Okay? And then our next perfect square after that is normally 4, but we're going to go right 3 from that 4. So what's our new x-coordinate there if we go right 3 from 4? 7, right. Okay, and we'll do one more here just to kind of finish it off. What about that 9? So again, our next perfect square after 4 is 9, but we're going to go right 3 from that. So now we are at what? Yeah, right 3 from 9, sorry. 12, yep. Okay, so those are our new x values. Okay, and then we can get the matching y values by just plugging them in there, or by typing into our calculator, going to the table, right? So if you guys never, I think we've done that, but I'll just show you here real quick. All right, so I'll do 2 square root x minus 3, close the parentheses, and then minus 2, and I'll go second graph, and it takes me to the table here. Okay, there's my table, and so we can see that for an x value of 3. There's my negative 2. At 4, we get 0. Okay, at 7, I got to scroll down here to get to 7. There's 7. At 7, I get 2. Okay, and I go down to the 12. And at 12, I get 4. Okay, so again, what did I do here? I typed the function into my y equals, and I did second graph to get to the table. Okay, we had to adjust our x values, right? We had the 0, 1, 4, and 9. we adjust those based off of the shift, right? We had to shift them all right 3. So 0 became 3, 1 became 4, 4 became 7, 9 became 12 there. And we can use our table to get the matching y values there. Okay? So, let's sketch the graph of this. Yeah, sorry about that. Yes. Okay. Okay, so we'll sketch the graph here. So, okay. So -1, -2. 1, 2, 3, 4. Oh, not -2, +2, 3, and 4. And then let's see, I got to go from 3 to 12. So let's say maybe I'll count by 2s here. So 2, 4, 6, 8, 10, 12. Okay. Something like that. And we'll just plot the points then. So 3, -2. 4, 0, 7, 2, 12, 4. Okay. And so there's the graph. Okay. So again, what did we do here, right? We wanted to sketch the graph of this, right? So we realized we had listed our transformations here, right? And we transformed our starting point, our reference point there, the 0, 0. We transformed it using the right 3 and down 2, right? So right 3 from 0 is 3, down 2 from 0 is -2. That gave us our new starting point. And then I went with the 1, the 4, and the 9, our perfect squares of what I had to transform them to this graph, right? So I had to shift that 1 right 3 units. So we go to 4, right? And then 4 I had to shift right 3 to 7, and then 9 I had to shift right 3 to 12. And you can just plug those in then, okay, to the function, or use the table on your graphing calculator to get the matching values, and then that gives you your curve when you plot the points there. Okay. One thing I forgot to talk about, if I go back up here to the parent function real quick, all right, what's the domain of this parent function? What is the domain of this parent function here, the square root of x? Where does it start? At what x value? 0. Yeah, 0 to infinity. Exactly right. Do we include the 0? Do we have a point there on 0? Yeah, so we're going to include it. And then it goes to infinity. What about the range? What's the range here? What's our lowest y value on this graph?
-2.
On the parent function back up here.
Oh.
What's the lowest y value there?
0.
Yeah, 0. And we go to infinity as well. Okay? Now if we go to this graph, Michael, you were right, okay? The lowest y value is -2, so for the range for this graph, it would be -2 to infinity. Okay? And then the domain, what would the domain for this graph be? What's the farthest left x value here?
2.
Well, it's supposed to be between the 2 and the 4. There should be a 3.
Yeah, 3. So 3 to infinity.
To infinity. Exactly right. Okay, so there's your domains and ranges. Okay?
So what was I didn't get the domain.
First one is just 0 to infinity, 0 to infinity. Okay? Sorry about forgetting that there, guys. Okay? All right. So if you're feeling good and you want to get started on the homework, I will give you guys the homework assignment. All right? If you want to see one more example, I'll show you one more example here too. Okay? So your choice. If you feel ready to go, I'll get started on the homework assignment. Okay? Or we'll have you we'll do one more example here. homework, if you want to get started on that, we'll be on start on page 362. And I'll have you do numbers. Let's see here. How about 2 through 5, 10 and 13. Okay. It's going to ask you to describe the domain and range using set notation. Please just use interval notation. I don't want you to have to worry about that. Okay. And, oh yeah, okay, and we'll do 20 as well. Okay. So there's your homework. If you want to get started on that, feel free. Or if you want to see this next example there. Okay. All right. So there's the homework, like I said. It should be good. And again, use interval notation, not set notation there. All right, one more here if you're interested. Show you another example. Okay. So we'll talk about this function here. Okay. See some transformations, right? So are we shifting left or right at all? Yep. Right. How much? 2. Yep. Right 2. Okay. How about up or down? Up. 3. Okay. What's that?
Shrink 3.
So okay. So so what's the negative going to do? It's going to actually reflect it over the x-axis. Reflect over x-axis. And then we will be, it'll actually be a stretch, okay? Because that number 3, it's more than 1, right? The number is just 3, and it's going to be more than 1. So it's going to make it stretch 3 as well. Okay, so we'll see what that looks like here. All right, so again, since we're going right 2 and up 3, that normal point of 0, 0 will transform to be 2, 3, right? We're going to go right 2, up 3, so we get 2, 3. So my table, we'll start at 2, 3. Again, that's like my 0, and then like my 1, and then my 4, and I'll go ahead and do the 9 as well there. Okay, so 1, I have to go right 2 from 1, so I'll be at 3, and then 4, I'm going to go right 2, so I'll be at 6, and then 9, I'll go right 2, so I'll be at 11. Okay. And then you can plug each one of these x values into your function there and get the matching y value, or you can do it in your calculator too. So -3 square root x minus 2 plus 3. Go to the table. So 3 will give me 0. 6 gives me -3. And 11 gives me -6. Okay. And then we'll just graph those points. Okay, so 1, 2, 3, 4, 5, 6. Oh, sorry. Thank you for saying that. 10, 2. Jumped way forward. 10, 2. I'll count by 2s here. So 2, 4, 6, 8, 10, 12. And then 1. Okay. So I count by 2s on my x-axis again, and 1s on my y-axis, just to kind of make it easier to get to those different points. So we have 2, 3, so 2, 3. and then 3, 0, and then 6, negative 1, 2, 3, and then 11, negative 6. Okay, so you can see that reflection. Right, you can see the reflection. You can see the shift and stuff like that too. What's the domain of this graph going to be? Close. It's 2, right? The farthest left we started there is 2. So, but yep, 2 to infinity for the domain. Oh wait, did I say range or domain? I said range. My bad. Yeah, it's 3 negative to infinity. 3 to negative infinity. But watch, we want to watch the order for that though. We want to say negative infinity to 3. Sorry about that. There you go. And then the domain would be 2 to infinity there. Okay. 2. Yep. Okay. Questions on anything there? Any questions on the graphs and stuff?